Hello everyone. So we're gonna start with question number 5 today. In this, the question says the moment of inertia of a uniform cylinder of length L and radius R about its perpendicular bisector is L. So what is the ratio of L by R such that the moment of inertia is minimum? Therefore, this will be a perpendicular bisector, length and radius is 2R, therefore diameter is 2R. Here we will see that L equals to mr square by 4 plus ml square by 12. Therefore, L equals to m by 4 r square plus L square by 3, which will give us the dl by dl equals to m by 4 minus v upon pi L square plus 2L upon 3 equals to 0. Therefore, v upon pi L square equals to 2L by 3. The L will get cancelled. Therefore, v will be 2 pi L upon 3 L cube by 3. Therefore, pi r square L equals to 2 pi L cube by 3. L will be here, it will give 2. Pi will get cancelled. So L square upon r square equals to 3 by 2. L by r equals to 3 root 3 by 2. Thank you everyone.